Welcome back to our live training tutorial here. We're going to be taking a look in this training module at how to dial in high cam or VTEC operation. So looking at fuel, spark, and variable cam control, and also setting our VTEC engagement point. Now we've dialed everything on for the low cam or non-VTEC, so we're going to be learning how to turn on our VTEC, how to configure our VTEC output table, how to figure out what the ideal VTEC point is going to be, and then map out fuel, spark, and variable cam. Now, the one benefit that we have going for us is that we've done a lot of the calibration work in our low cam tuning tutorial. So meaning our spark timing is going to be relatively close to start off in our VTEC operation. We'll also find our fueling should be ballpark close. It's probably going to need a little bit more fuel. We'll deal with that in the estimate table. And the variable cam control is something that we do have to sort out in this training module. Let's jump in and take a look at what we have to set up and configure. Then we're going to go set up our dyno to do our full throttle pulls. We'll start to do our baseline pull and then just rapid fire through all of the calibration changes we need to make in order to get our engine dialed in. So this video won't be as long as our last low cam tutorial. That's really where we spend the majority of the time for the calibrating and tuning, and it does set us up again for dialing in VTEC or high cam for this particular training tutorial or this step in the calibration process. All right, let's jump in here. First thing first, we need to understand that we have one estimate table, one spark timing table, one variable cam control table. We don't have dual tables that we can work for both low and high cam. We can switch between based on the cam profile or based on when the VTEC is switching on or off. So we have to make everything work within one table. So we have to be careful about how we calibrate things, so to speak. What we're gonna do is jump into our, let's go here to setup, and we're gonna move across here to all calibrate. I'm gonna move down here into the aux output, which is assigned for my VTEC control, which is my aux 2 on my particular harness here that I'm working with. Let's go to output 2. We can see we've assigned it to a half bridge output. The half bridge output sending a 12 volt out to turn on the VTEC control solenoid. There's going to be grounded to the actual cylinder head, so the actual solenoid itself is grounded to the block or the cylinder head, and we're sending the 12 volt out in order to complete the solenoid activation and to engage it. And when we do that, oil flow is going to go through the oil passages into the galleys, into the rocker arms, and lock the sliding pin for VTEC to activate. And then we want VTEC to turn off, we'll deactivate it here, and the slider pin will come out and the rocker will go back to the low cam lobe. So it's a pretty trick system. It's been around for a long time and it works great. And VTEC engines, they make great power for what they are, for the displacement and the size of the engine. So let's jump in here, take a look. We see resource, again, half bridge output. We're sending a 12 volt out to control things. So in our duty cycle table, this table can be controlled with a half bridge output, either in a positive or a negative duty cycle. Because we're working in an on-off type control, we want to make sure the frequency here is at 0 hertz. This is telling the Motec that we're just doing a basic on-off control and not pulse width modulated. Now, the next thing we need to take a look at here is how we set our values in the table. Because we're working with a high side output or sending a 12 volt to the control solenoid, we want to put a negative value in our table here. So, in fact, we want to put a negative 100 in order to turn on the VTEC solenoid when we want it to engage. And we have to do this very specifically. We want it to engage based on RPM, but we also want to go and engage it based on throttle position and possibly manifold pressure. So a lot of things to think about here. Now, when we're talking about an alpha end strategy, I'm really going to focus on just engaging it based on throttle position and engine speed. When we were looking at the other live training tutorial with the same vehicle with drive-by-wire, we set a manifold pressure threshold, throttle position, and engine speed. Alpha end, we're just going to do throttle position and engine speed. Now, how do we do that? It's pretty simple. Let's click into our table right here. I'm going to click A, and we see we have some options here to configure the table. We're going to do an engine speed throttle position. So let's click on axes, and let's go to generate, and we're going to go here from 1,000 RPM, and let's go up to something like 9,000 RPM, and we're going to move in 500 RPM increments and click OK. And then under throttle position here, we're going to engage this. We'll go to generate, we'll go to 0 to 100 and move in 10% increments. This now is going to give us a 3-dimensional table for control. Now, I'm going to lock my VTEC at a pretty low engine speed, so it's locked on, and we can begin our calibration process locked into the high cam. And when we do this, we want to go into the table here at 3,000, for example, and go and set this so it's going to be locked in at that specific RPM range. I'm not going to care at this point about throttle position, so I'm going to go grab the entire table value here in the column, go all the way across, and then type in negative 100. So at 3,000 RPM, it's going to fully engage the VTEC. Anything below that, VTEC will be off. Anything above that, VTEC will be on. So pretty simple. This is going to give us just a simplistic way to lock VTEC in to start our calibrating and tuning. So that's getting that out of the way. We do want to check our other activate conditions. We want to make sure that the pressure, intake manifold pressure minimum is 0, maximum is 400, speed minimum is 0, maximum is 400, and the hysteresis here are both 0. This just makes sure we're getting rid of those variables or parameters for activation thresholds. We're just basing our table purely based on engine speed and throttle position. That's all we need to do for an alpha end strategy. All right, so hopefully that makes sense. Now, the next thing we're gonna do is jump into our variable cam control table. Let's go back here to tuning, and let's go in here to inlet cam VVT. So in this table, I'm gonna go ahead and zero out my variable cam. Now we know on low cam, what we have here was the optimized variable cam blend. But now we're locking in high cam, and things are definitely gonna change. So because we only have one inlet cam target table to deal with for both low and high cam activation, we essentially have to bridge the gap and allow both the low and high cam for cam angle to be characterized on a single table. Now it's much more ideal to have two tables, but we don't have that luxury with this firmware package or any Motec firmware package, so we have to get creative how we do this. What I'm going to do is just set my inlet manifold pressure here from 70 kPa and above to 0. So we're gonna zero out what we've done on the low cam, and we're gonna go ahead and do a pull on high cam and figure out as a baseline where we're at. We're gonna adjust our estimate table values based around VTEC being on that 0 degree, and then we're going to just do pulls and walk up the variable cam timing and figure out what is going to be optimal for this engine. Usually at high engine speeds, we're not going to roll it back to 0. We might roll it back to something like 20 or 30, but the mid-range we might have as much as 50 degree if you have a 50 degree VTC gear, which I actually have installed on this engine with OEM cams. So this is going to be how we prep things to do our base pull. We know that the estimate table should be fairly close. It's probably going to be off a little bit. The closed loop correction is going to do the work and fix it for us, and then we can go in and clean up the actual estimate table to get our fueling in line. Everything should be good, at least for the baseline pull. Now the other thing to keep in mind here is ignition tuning. We know we ended up with 24 degrees of timing on low cam. We're going to be able to run at least this much timing on high cam, possibly another degree or two more when we're on VTEC activation. Cylinder pressure changes a little bit, we have a little bit better breathing. As a result, we can usually get a little bit more aggressive with our spark advance without running into knock. We'll have to experiment with this, but these values that we found for low cam will work perfectly fine and be completely safe for high cam engagement. All right, now that we've covered kind of where we're at here and know what we have in terms of our tuning and calibrating process, which is going to be, real quickly, just to make sure we're clear on this, dial in our fuel, then go in, walk our variable cam up, figure out our cam composite blend, just like we did on low cam. Then we're gonna go back into the estimate tuning table. We're gonna go dial these values in based on the composite blend. Then we'll go after spark timing and walk that up a little bit. And then we're gonna figure out the exact VTEC engagement point. We need to do that after everything is fully mapped out. All right, so now that we have our plan in place and we know what we're gonna do, let's jump into the dyno screen to set this up. So moving into the mainline dyno screen, this is our main run screen. This is going to be where we control things for, let's say, part throttle.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.